In this video, we're going to talk about multiplying and dividing rational expressions. We've already talked about simplifying rational expressions, and so we're going to look at multiplication of rational expressions. Remember how when we multiply fractions, such as 2/3 times 5/7, we're literally just going to multiply numerator times numerator and denominator times denominator. So that's going to give me 10/21. Now then, there are at times when I can simplify, such as if I start out with 15/14 times 21/10. There's a couple of ways I can simplify this particular problem. I can rewrite 15/14 as 3 times 5, looking at their prime factors, divided by 2 times 7. And I can look at 21/10 as 3 times 7, divided by 2 times 5. And since everything is multiplied, now what I can do is I can simplify numerator to denominator. And I'm going to mark out a 5 and a 5, because what it is a 5 divides into 5 one time, and a 5 divides into 5 one time, and a 7 divides into 7 one time, and a 7 divides into 7 one time. So what I'm doing is I'm crossing out numerator to denominator, numerator to denominator. And it can be diagonally or it can be straight up and down, as long as it is a numerator to denominator situation. Notice I am not crossing out this 3 and 3 because they are both on the numerator, and I'm not crossing out the 2 and the 2 because they are both in the denominator. It has to be numerator to a denominator situation. Once I have crossed everything out, then I can multiply straight across what is left. And I have 3 times 1, which is 3, times 3, which is 9, times 1, which gives me 9. On the denominator, I have 2 times 1, which is 2, times 2, which is 4, times 1, which is 4. And this way, it is already in the most simplified version. I could have multiplied 15 times 21 and 14 times 10 and then simplified. But that gives me really large numbers, and sometimes I don't know what to simplify by. This also will cause us problems when we're working with rational expressions if I do not factor first before I do the multiplication. So when we're looking at multiplying rational expressions, so for multiplying rational expressions, our first step is going to be to factor the numerator and the denominator completely. We always want to completely factor. That means to factor out the GCF, factor out the completely as usual. And then step 2 is we want to simplify and what we're doing there is we are crossing out numerator to denominator. In other words, we cross out numerator to denominator, and it's a 1-for-1 situation. We could simplify if it was a 4-to-3, things like that. I'm sorry, a 4-to-8, but if we factored it out completely, it's a 1-for-1 situation. Okay? Step 3 is we are going to multiply oops, not an M, I want an N, numerator to numerator, and having a little bit of trouble there. Let's see, numerator to numerator, and denominator to denominator, just like we would any other fraction, okay? And this will give us our most simplified form. And I will go ahead and say we leave them in simplified version, so we don't actually go ahead and distribute or anything like that. We just leave them in factored form when we multiply, when we're working with rational expressions. So let's go ahead and look at some examples of this. I want to multiply if I have 7a over 3b times 15b over 14a squared. Now let's think about, since I'm multiplying, let's rewrite this in factored form. And it may look like it's already in factored form, but let's write it out where we have all of the variables written out and all of the numbers as factored down as possible. And when I do that, 7 is a prime number, so that's as far down as it can be written. And a, I just have one a. 3 is a prime number, so that's as far down as it can go, and I just have one b there. But over on this other fraction, 15 can be factored down into 3 times 5. And then I have 1b. 14 can be factored down into 2 times 7. And then I have an a squared, which is a times a. So notice I have rewritten this 14a squared into its prime factored form. That way I can cross out 1 for 1. And what I'm going to do is I'm going to say, okay, I have a 7 here and a 7 here. I have an a for an a. I also have a 3 for a 3. And I have a b for a b. That way I can look and I say, okay, what I have left is I have a 5 left on the numerator. On the denominator I have a 2 and I have an a. So I have 5 over 2a. So if you'll write it out in factored form first and cross out numerator to denominator, that will help you see exactly what you have and where you have it left, whether it's in the numerator or the denominator. Let's look at another example. Okay, let's look if we want to multiply 4x minus 8 divided by x plus 6 times x squared plus 6x divided by 2x. Okay, we need to make sure that we factor each numerator and each denominator. So let's look at this first numerator. What is my greatest common factor? Well, my greatest common factor is going to be a 4. So I'm going to factor out a 4. That leaves me with an x minus 2. On the denominator, well, that's as far factored as I can get, so that leaves me with an x plus 6. On this numerator, I have a greatest common factor of an x. So I'm going to factor out an x, and that leaves me with an x plus 6. On the denominator, I have a 2 and I have an x. Well, I'm going to look at something. I have a 4 here. Can that be written smaller? It can, or I'm going to show you what else happens. Okay? So I have a 4 times x minus 2 times x plus 6, and I have an x plus 6 and a 2x. So let's see what all we can cross out. Well, I have an x plus 6 here and an x plus 6 here. So those can cancel out. I have an x here and an x here. Those can cancel out. The other thing that can happen is the 4 and the 2. 2 goes into 2 one time. 2 goes into 4 two times. Let me kick it over here. If I had rewritten this 4x minus 2 over x plus 6 times x plus 6 over 2x, I could have rewritten that as 2 times 2 x minus 2 over x plus 6 times x plus 6 over 2x. And that way I would have marked out a 2 and a 2. Oop, I left out an x. An x and an x plus 6 and an x plus 6. And notice what I'm left with on both sides. I'm left with a 2 on the numerator and an x minus 2. So I'm left with a 2 and an x minus 2. Over here I'm left with a 2 and an x minus 2 on the numerator. On the denominator, I'm actually left with nothing, or a 1. You can either write it with a 1 underneath, or you can just write it with a 2 and an x minus 2. Either way is fine. But notice here I could divide the 2 into the 4, or I could have rewritten the 4 with a 2 times 2. It works both ways, okay? Whichever way is easiest for you. As far as, do you need to see it written with all your factors, or can you see that 2 will go into 4? That is completely up to you. Let's try one more multiplication. So let's look at if we multiply p squared plus 4p plus 3 divided by 5p plus 10 times p squared minus p minus 6 over 9 minus p squared. Okay. Notice that each numerator and each denominator is going to need to be factored. So this may be where, over on the side of your paper, you may have to do a little bit of work for factoring. So let's look at the first numerator. P squared plus 4p plus 3. Let me scroll this over just a little bit. So I want to multiply to get me a 3, add to get me a 4. Well, that's going to be 1 and 3. So that's going to be p squared plus 3p plus 1p plus 3. So I can take out a p. So that's going to be leaving me with p plus 3. I can take out a 1, leave me with a p plus 3. So I end up with p plus 3 times a p plus 1. So that's going to be my numerator. P plus 3 times p plus 1. Now my denominator here, I can factor out a 5 and get a 5 times p plus 2. Okay. Now let's look at my numerator over here. I've got p squared minus p times, minus 6. So I've got p squared minus p minus 6. I want numbers that multiply to give me a negative 6, that add to give me a negative 1. That's going to be a negative 3 and a positive 2. So I can factor out a p. That'll leave me with p minus 3. And I can take out a 2. That'll leave me with a p minus 3. So that's going to give me p minus 3 times p plus 2. So let's see here. That'll give me p minus 3 times p plus 2. Okay. Looking at this 9 minus p squared. Notice everything else has the p in the front. So let's look at that 9 minus p squared. First thing I'm going to do is I'm going to rewrite that as p squared plus 9. Okay, I wanted to make that p squared positive, so I'm going to factor out a negative. Looks like that. Now I have a difference of squares. So that leaves me with a negative p minus 3 and a p plus 3. So, and I have to make sure that I bring that negative over. So I get a negative p minus 3 and a p plus 3. Now that everything's factored, now I can go through and start marking things out. So I've got a p minus 3 and a p minus 3. I've got a p plus 2 and a p plus 2. I've got a p plus 3 and a p plus 3. I have to be careful because I've got this minus sign. Okay? What happens is that minus sign just comes out to the very front of our equation. And I have a p plus 1 on the numerator, and I have a 5 on the denominator. I can write it as a negative p plus 1 over 5. Some people also write it as a p plus 1 over a negative 5. You just have to be careful. If you put it in the numerator or denominator, make sure you put parentheses around whichever one is there. If you put it out in front of the entire thing, you're okay because you know that you'll have to distribute that negative. Okay? So whenever you have these, we're still going to be doing a lot of factoring. Multiplying, we're going to factor and then just go straight across. When we start to divide, we have to add one more step to this, and that one step is we have to change it to multiplication. So for dividing rational expressions, we've got to add a step. And that first step is going to be to do what we say keep. And let me go ahead and keep, change, flip. What this means is we are going to keep the first fraction, change the sign from multiplication to we're going from division to multiplication, and we're going to flip the second fraction. Our second step is we are going to factor all numerator and denominator completely. Third step is we will simplify, and that is the crossing out one for one numerator to denominator. And our fourth step is to multiply. That's numerator to numerator and denominator to denominator. So the biggest change here is this first step, what we do, keep, change, flip. What we're doing is we're changing the division into multiplication. Really, when we're talking about fractions, there is no such thing as division. We change it into a multiplication problem. So let's look at what we're talking about. So if we want to divide 7y minus 14 over y plus 1 divided by y squared plus 2y minus 8 over 2y plus 2. Okay? The very first step that we're going to do is we are going to keep the first fraction the exact same, 7y minus 14 divided by y plus 1. We are going to change this from from division to multiplication. And we are going to flip this fraction. We're going to put it 2y plus 2 over y squared plus 2y minus 8. We're getting its reciprocal. We're flipping it. Okay? Now, it is a multiplication problem just like what we've been doing. So we're going to factor each one of these and then multiply. So for the first one, numerator, we're going to factor out as 7. Leaves me with y plus 2. The denominator is already in factored form. Times the second fraction, the numerator, I can factor out a 2. Leaves me with y plus 1. The denominator, I'm going to come off to the side and say y squared plus 2y minus 8. I need factors of a negative 8 that add up to a positive 2. That's going to give me a negative 2y and a positive 4y. So I will factor out a y. And I can factor out a positive 4. And that will leave me with a y minus 2 and a y plus 4. And so that gives me y plus 4 and a y minus 2. And I have a wrong sign right here. Let's see. Yep, right here. That should have been a y minus 2. My apologies. Okay, now we can simplify 1 for 1. We've got a y minus 2 and a y minus 2. A y plus 1 and a y plus 1. Which leaves me with 7 times 2, which is 14, over y plus 4. So again, our biggest challenge is making sure that we change it first to a multiplication problem. Let's try one more of these, and that's going to be to divide 4x squared minus 9 over 2x squared minus x minus 3 divided by 20x plus 30 over x squared plus 7x plus 6. Okay, it's division. So my first step is to keep my first fraction and change it to multiplication and then flip my second fraction. So I now have x squared plus 7x plus 6 over 20x plus 30. Now I need to factor. So I have 4x squared minus 9. That 4x squared minus 9 is the same thing as 2x squared minus a 3, not equal 3, minus a 3 squared. So it's a square minus a square, so that's going to be 2x minus 3 and a 2x plus 3. So 2x minus 3 and 2x plus 3. Then we have 2x squared minus x minus 3. So I want to multiply to give me a negative 6, add to give me a negative 1. That will be a negative 3x and a positive 2x. So I'm going to factor out an x. So that's 2x minus 3. And I'll factor out a 1. So that's 2x minus 3. So I have 2x minus 3, x plus 1. So I have 2x minus 3 and an x plus 1. Then we have the x squared plus 7x plus 6. Factors of 6 that add up to 7. It's going to be x squared plus 6x plus 1x plus 6. Take out a 6. I'm sorry, take out an x. Take out a 1. And I get an x plus 6 and an x plus 1. Okay. Which leaves me with an x plus 6 and an x plus 1. Then on the denominator, I'm going to look at 20x plus 30. I'm going to factor out a 10. It's leaving me with a 2x plus 3. Now I get to start crossing out 1 for 1. So let's see. I can take 2x minus 3 and a 2x minus 3. I can take an x plus 1 and an x plus 1. I can take a 2x plus 3 and a 2x plus 3. Okay. That leaves me with an x plus 6 over 10. And that is my divided rational expression in simplified form. Now please do not simplify the 6 and the 10. Because of this plus sign, I cannot simplify those numbers. This has to go as a group. The x plus 6 must go as a single group because it is a single factor. Okay? Try some of these and then let me know if you have questions.